We will look at the sound booklet, the answers, the explanation, the strategies to answer them. Intruder alarm. What should be the amplitude and frequency of the sound without affecting the pitch? It should be the amplitude should be lower and the frequency will be the same. This because it gives a quieter sound, so amplitude should be lower. From a satellite, sound cannot travel. It cannot travel in vacuum. Why are we rejecting these? Because water, sound does travel. It uses sonar, explosion. Underground, sound does travel through solid and a balloon filled with helium gas. There is a medium, so sound does travel through it. 3. Loudness of Y with X. Y is louder because it has a higher amplitude, greater amplitude, and has a lower pitch because X has a greater frequency. Frequency is related to pitch, and amplitude is related to the loudness of the sound. Number 4, what is the difference? It is the quality. They both have the same frequency, same amplitude, and if they have the same frequency, they will have the same pitch. It is just that this is a simple one sound, and this is sound and position superposition of another sound on it. So, an echo produces ultrasound 24 kilohertz, and it travels with this speed. V is equal to F lambda. Lambda will be V. Sorry, lambda will be F divided V. 24 divided 1.5. Kilo should cancel. Kilometers per second. This will be 1/second. So the left is kilometers converted into meters, 0.063. Loudspeaker produces 50 hertz. Amplitude is increased, a louder sound of the same pitch because amplitude has only to do with the loudness, nothing to do with pitch. It can't be same loudness and it can't be uh, same loudness again. Ultrasound scanner, baby scanner, scanner form an image from ultrasound reflected by the baby in the womb. So we have the siren, an echo is heard. 4 seconds later, after the siren is sound. So sends the sound, comes back in 4 seconds. The distance is twice and the speed is 320. The expression you will be using is here. The formula that will be used is speed is equal to twice the distance over time. And we multiply the time with the speed. The time is 4 seconds. The speed is 320. Okay. And then we have 2s on the right side. We divide the left side with 2 to get distance. That will be 640. Compressions and rarefactions. So at P, there is a compression. And at here is rarefaction. The frequency is 50 hertz. How much time lapses before the next rarefaction arrives at P? So we have, how many wavelengths we have? We have exactly one wavelength. So one wavelength. Now let's calculate the wavelength from the frequency. It will be 1 over, sorry, frequency. Using the frequency, we can calculate the compressions, frequency, how much time frequency gives us the time period, and it will be f is equal to 1 over t, 1 over 50, and that should give us 1 over 50 means 0.01 seconds. Speed of sound is faster in solids. Okay, speed cannot travel in vacuum. Fastest in gases, no. Slowest in gases, then faster in liquids, and then fastest in solids. Remember this from your knowledge. Ultrasound is between 20 to 20 kilohertz, so 35,000 means 35 kilohertz. So, sorry, ultrasound is greater than 20 kilohertz. So that's the only one that is greater than 20 kilohertz. They're all less than 20 kilohertz. So we have a student 200 meters from the cliff. Two pieces are hit together to produce sounds, and the stopwatch is stopped. So we calculate the average of the time, that gives us the time, and then the distance is calculated using the 200 meters time twice. Again, the formula will be speed is equal to twice of the distance divide time, and the distance calculated and then divided with 2, you get this one. Same question, repeat. So we average these, we have the speed, again, twice, speed is equal to twice distance over time, calculate the distance, 1.2. Ultrasound has many uses. Prenatal scanning. It is not used in any of these. Audible frequencies are in this range. Again, highest to lowest will be solid, liquid, and gas, speed of the sound. A guitar, pitch of the note rise is an increase in the frequency of the guitar will make this. Frequency of an ultrasound will be greater than 20 kilohertz, so it will be 30 kilohertz. Which point represents a compression? It is B, because B as a compression in this form will be the crust. These two sounds, the timbre is different. They have the same frequency, same wavelength, everything same, speed same. It's just the quality of the sound. This is a different music. This is a different music. This question will be done using the same expression, equation. Speed 2 times distance over time, put the values, calculate. Sound travels at different speeds, slowest in air, fastest in steel. Again, the quality is difference. Distance, time, speed. Speed is equal to twice the distance over time. Calculate this and you get this answer. So we have again another, so we use the same expression to calculate this. Each pair of values, we will use speed and time. We don't need frequency for sound calculations. So loudness and pitch are increased. If you increase the loudness, it goes like this. Increase the pitch, frequency increases, only this one. Reject these because this has the same sound, just given one more wavelength shown. This has a larger amplitude but same frequency, and this has a smaller amplitude. This is the next question. This is a question from next chapter, but we'll do it. Soft iron is used because it absorbs all the magnetic flux. This is a tricky question. Make sure you follow it. So the girl emits the sound. It travels both ways. When it travels this way, it also travels this way. When it is heard by the boy first, it would have traveled some distance, 350 meters. So 150 and 200 here. So subtract 350 and 200 give 150. So 150 meters will be heard by the boy in 1 second. So if you hear 150 meter in 1 second, what is the speed of the sound? Twice the distance gives you 150 times 2, 300. So how long it will take? It will take less than a second. Why? Because 1 second after the fence is struck, the girl hears the sound through the air. So 1 second after, that means the girl is producing a sound that will go through it in less than a second. Because it is the solid, the sound in the solid is faster than in the air. Loud and low pitched. So if it is loud, it will have more amplitude. And if it is low pitched, it will have less frequency. So A will have a least in both, and more in sound, more loud, less frequency, least frequency. What is P? P is the wavelength. So P is the wavelength, Y is the amplitude, X is the wavelength, sorry, not P. So reject everything but X, and then P is where the compression is, Q is where also the compression is. So the rarefaction, sorry, P is where the compression is, Q is where the rarefaction is. So accept these two values. So we have a loudspeaker at P, and this is the frequency, the time. 200 frequency means 1/200 seconds. In 1/200 seconds, sound will be going like this, coming like this. Molecule will vibrate like this, in this much. So molecule will vibrate once in 1/200 seconds, which is the frequency, and will go like this and then come back. Sound wave. An explosion in outer space does not produce a sound wave. Thank you.